Alright, welcome to video number 4, and we're actually going to get back to physics this time, because physics is awesome. And so we've done a lot of math stuff, and now we're going to get back into physics, and we'll use the math stuff not in 3.4, but in 3.5. So, we're talking about projectile motion, which is just like everything we looked at before with acceleration of objects, particularly in free fall. But we're looking in 2 dimensions, so we're moving horizontally and vertically. So if a ball is thrown perfectly horizontally off of a cliff, like our little diagram here, which path does it follow? A, B, or C? We'll go through this bit by bit. If it's moving horizontally, it should probably continue moving horizontally. So that means A is not an option. And then we're choosing between B or C. If you think about it's in the air, there is acceleration, that means it is speeding up in some way. Speeding up usually is represented by curves. So C is indeed our best option here. So it will follow a curved path off of the edge of the cliff. And the reason for that is due to gravity. So let's take a look at 2 examples. One in 1 dimension, so what we've done, and then see what happens in 2 dimensions. So we've got a rock on top of a cliff. How long does it take to land? We've got our givens. Let's just go for our equation. We have d, a, v naught, and t. Our best equation is most common equation, as it almost always is. D equals v naught t plus 1/2 at squared. This part goes to 0 because we're dropping it. Our initial velocity is 0. D equals 1/2 at squared. And now we have to isolate for time. And if you do this enough times, you'll be able to do it fairly quickly, just like this. And we take the plus or minus. We know for time the negative answer will never be a logical one, so we can ignore it from now on in our solution. So we have 2 times 652 meters over negative 9.8 meters per second squared. But we have somewhat of a problem because we're going to end up with a negative number underneath our square root. And that's because of the cliff. Remember, when we're dealing with things in free fall or vertical motion, we have to think about the direction. If we're at the top of the cliff and we've gone to the bottom of it, we've gone down, which is a negative direction. So we've actually, D, although it's positive in our question, is actually negative for our calculations. That will allow us to cancel out that negative, get a positive number, and we get the time coming out to proper sig figs of 11.5 seconds. So, not a hard problem in terms of kinematics, what we did in our last unit. Now let's look at 2 dimensions. Now we're throwing it perfectly horizontally, and what happens? We know it follows a curved path, but what does that mean? To make it easier, what we do is we always look at our horizontal things and our vertical things. So let's take a look at what we know for this problem. We know it's thrown perfectly horizontally, so it has some initial v in the x direction. Don't know what it is, we just know it has it. We don't know how far away from the cliff it goes. We don't know anything about acceleration in the horizontal direction. And we're looking for time. So there's a lot of question marks in our horizontal motion. Our vertical givens, if it's thrown perfectly horizontally, that means it's not moving up or down, so that means it's actually got 0 initial vertical. And dy, well, dy is vertical, which is the height of the cliff, so that'll be again negative 652 meters. Ay, vertical, things in the vertical direction for acceleration, gravity. So we have ay, which is negative 9.80 meters per second squared. And we're looking for time. Now, compare that to the horizontal, which is a whole bunch of question marks. We've got 3 things and we want another one. So if we were just looking at the vertical part of our motion, we could solve this problem. And that's exactly what we have to do. So in our vertical motion, we have to do is solve for time. And we're actually going to use the same equation we just did, but we'd have to identify that we're doing vertical motion only. So we have to have our y's everywhere for our appropriate variables. And again, v naught is 0, so that cancels out. We get dy equals 1/2 ay t squared. T equals positive minus square root of 2 dy over ay, which is the square root of 2 times negative 652 meters over negative 9.80 meters per second squared, which, if you think about it, should be exactly what we had before, 11.5 seconds. So even though this ball, the same rock was thrown horizontally, it still takes exactly the same amount of time to go through the air. And that's a very important concept for horizontal projectiles. And there's going to be a video link that pops up that takes you to a demonstration of this exact idea, and we'll talk about it and do it in class as well. Hopefully you went and took a look at that video, and now maybe you have some questions about it, so keep those questions in mind for class. Let's go through some concepts here. So it makes no difference whether the object falls straight down as a projectile. The vertical acceleration is gravity, and it's exactly the same. It's no different because we're just looking at vertical motion, how it changes vertically. Horizontal motion will never affect that vertical motion, which is why it takes the same amount of time. So even though it moves horizontally, the vertical motion is identical, and so it takes the same amount of time. And what we'll have to do in 3.5 is look at the horizontal parts and the vertical parts, and we'll have to do it for this as well. So we will only look at x parts and only look at y parts. We can never look at them at the same time. So we'll go through a couple of examples on how to do that. So we're always looking at horizontal and vertical differently. Always, always, always. That is the absolute key. So anything that has both horizontal and vertical motion is a projectile, and that's exactly all we're going to be studying for 3.4 and 3.5. And if you wanted the velocity at the very end, you'd have to combine the velocity components, but that is only if the question asks for it. We will use x and y, so we don't have to use our vector notation, which is, for some people that'll be a good thing. Now let's look at what our equations will look like. Horizontally, we actually have 0 acceleration. Our acceleration, if we're in free fall, is caused by gravity, which is pointed downwards, which is vertical. So horizontal has no acceleration, which means it's constant velocity. So our only equation that we can use is tx equals vx times t. And that's so that v naught x at the beginning is vx at the end. Now vertically, it is more complicated because we have acceleration, but it's exactly like we've studied before. We're just having two things going on at the same time. So vertically, we've got our same equations but with y subscripts. You will not get these on your equation sheet because they are exactly the same, just given a y subscript, and they don't have vector arrows, so they are otherwise identical. And to ay dy. Same equations, just given that. And ay will always be negative 9.80 meters per second. For projectile motion, it's just like free fall, always going to be that situation. So let's look at how to solve an example. We've got another stone. We like to throw stones for projectiles. It's just easy. And we're throwing it horizontally off a cliff again, but this cliff is 78.4 meters high, and we know how fast we're throwing it, 5 meters a second. And we're trying to find out how long does it take for the stone to reach the bottom of the cliff, which is the same problem we did before. So let's take a look at how we did that again. Now, we don't know a lot about our x direction right now. We know the speed, we don't know the time, we don't know how far it goes, we don't know anything about the x direction. So we'll have to use, we'll use the vertical motion. So we're only using y directions to solve for time because we just don't have enough information about the x. So we're looking for time, and we've got all that information, so we're going to use the same equation that we did because it is the same problem as we've done before. And this cancels out to 0, dy, and then t equals this. Plug the numbers in and you will get exactly 4.00 seconds. Okay, so we've now got the time. Part B asks us for how far from the base of the cliff. So if we think about our diagram here, we're going from here to here, which is how far horizontally, so this will be dx. So we're looking for dx question mark. So horizontal motion, so here we've got horizontal, we're not looking at anything vertical. Think back to our list on the previous page, we have one possible equation, dx equals vxt. We know what vx is, we just figured out time, so we have 5.0 meters per second times 4.00 seconds. That's going to give us 20. 4 times 5 is 20, but we have to make sure it's got 2 sig figs, so we get 2.0 times 10 to the 1 meters for dx. We've done A, done B. Now let's figure out C. What does C ask us? Well, what are the horizontal and vertical components of the stone's velocity just before it hits the ground? So we want Vx and Vy. First one's really easy. So remember, horizontal velocity is constant. Remember this. So v naught x equals Vx, which is 5.0 meters per second. It is constant, it will not change, there is no acceleration horizontally. So now we have to look at our vertical. So for our vertical, we want Vy. Now we have all kinds of information. We've got our dy, we've got time, we've got ay, we've got v naught. So we've got way more information than we need. So let's pick our easy equation. If it's thrown horizontally, we're assuming that the vertical motion is 0, so that is 0 meters per second. So we just have a times t. A is 9.80 meters per second squared. We just found our time to be 4.00 seconds. So Vy is negative 39.2 meters per second. So for all these projectile problems, only look at horizontal or vertical. Do not try and combine them. Stick to only looking at all vertical or all horizontal at a time. There's lots of more practice in the textbook, and don't forget to check out the quizzes on formative, and bring any questions you have to class. We'll go over lots of them. We'll do some demonstrations with horizontal objects and learn a bit about why physics is awesome.